Hello, my name's Jason. I'm not an archaeologist, but I do play one on TV. So come join me as we go into the dust.
This show has been brought to you by the letter B.
Welcome to the second edition of the ABCs of Archaeology, which would bring us to the letter B. Now, B in my world is for bioarchaeology. And I'm going to go here with a pretty broad definition of that, inclusive definition, which is the study of all kinds of organic remains at archaeology sites. So that's primarily concerned with humans, human skeletons, human soft tissue, human hair, and increasingly human DNA. But of course, there's also animal and there's plant. So, in this sort of traditional definition, people usually were only talking about human and pretty much human skeletons because it hasn't been, until maybe the 20th century that we started really finding a lot more than that. Outside of mummies, and that it was really being studied. Speaking of mummies, thinking about what people valued back in the day, people wanted to find treasure. They wanted to find gold and artwork. Think Indiana Jones. Well, a lot of times those bodies, the biological remains at the site, were unwrapped for public spectacle. They were actually eaten for centuries, ground up, I'm not kidding, and made into powders that were sold all over Europe. And people drank and ate those mummy remains because they believed that it had health qualities. I think it was some mistranslation of something from Persia. But yeah, the point is that was not valued as an archaeological source of information. Okay, so starting off with the main event, human skeletons. Human skeletons can teach us a lot. And, for quite a while, this has been developing into a science. Now, there was a pseudoscience as well, where people were doing phrenology, measuring stuff about the size of skulls and what that said. That went away in the 1800s, maybe some of it in the early 1900s. But there's stuff we can tell about the skeletons. Oftentimes, if we have a reasonably complete skeleton, we can learn about the person's sex. There's certain bones, like the hips, that people look for differences between male and female bodies. Oftentimes, stuff about the skull as well, and that's been understood for quite a while. Now, it's not foolproof, but if you don't have the budget for DNA, it's not a bad test. Uh, they can also tell about the age. That has to do with wear and tear on the teeth, often of animals, humans maybe, but probably more to do with diet on the humans. That has to do with the fusion of bones. So they can tell by looking at skeletons to a fairly precise level at the young age. Is this a prenatal infant, or 0 to 1, or even by months they'll break it down. As you get older, you go into more ranges, like above 45, depending on the site you're on. Teeth are really important. Teeth, you can get isotopic information. We'll talk more about that. We can also see a little bit about aging in teeth, as I mentioned, with animals. Um, uh, Also, the bones can tell you stuff about how those people lived. You can see injury on the bone, and that's been something I've studied a lot recently. You can find out to a fairly precise manner of how someone was killed on the battlefield and with what. And there's a lot of really cool examples of that. I could do a whole show just on that. So, bones can show you how somebody died if they died violently. They can show you how they lived. So, a lot of times they can tell if someone was a laborer or a slave or whatnot based on the wear and tear on their bones. If you pulled something, that's going to leave actually marks on your skeleton. You can see diseases on skeletons. And you can also get some sense of how healthy the person was in general, like with diet, etc. So, especially when they were young, because that's when that would affect your skeleton. So, there's quite a lot that human skeletons have been able to tell us for some time. Now, in the last 20 years or so, 20, 25 years, we've gotten a lot more information out of skeletons than previous. Now, the really fun stuff has come in the last 25 years or so with all the advances of science that we've gotten, and there's two kinds. So the first thing are isotopes. Isotopes are found in people's teeth. That's where they're extracted from. And this is really cool. So essentially, an isotope leaves a certain imprint on, a signature, let's say, in the mineral that it's in the tooth. And you can look at those signatures and match them to different geographic areas. So, what do I mean? So, for example, you can test the strontium in somebody's tooth. And where strontium hangs out in the world is that's in the bedrock, so beneath the soil. And over time, as the soil is sort of produced and the bedrock is worn down and it mixes into the soil, that strontium gets into the soil. Strontium goes into plants. Strontium is eaten by animals. Ant and plant animals are eaten by human. And you can tell where that person grew up because specific areas will have specific strontium signatures. Now, as you could see, that's quite complicated. There's margins for error. You have to build up a profile of strontium in the bedrock and in the soil around different parts of the earth because there's going to be some overlap. You're getting a strontium measure from the person's tooth, but how do you match it to something? You need a good catalog of the different strontium levels around the world. So that's something that's improving all the time. So strontium tells you quite a bit about what someone ate. There's also oxygen. That has to do with the drinking water. Don't ask me to explain it because I don't really know, but it has to do with the rainfall that leaves different oxygen signatures in the water, and then people drink water, and you can find out where they were when they grew up as their skeleton was developing. Now, there's all kinds of other ones. There's nitrogen. I think they used lead for a little while. Now, there's other ones as well. There's carbon, there's nitrogen, there's sulfur. Those, I believe, mostly tell you about what somebody ate. So there's different levels, for example, if people ate more fish or animal protein. And there's fun stuff that comes out of that. So like one thing that we've seen, and you can see this around the world if you travel, is there are some places that are surrounded by the ocean. They're islands or they're places with lots of peninsulas and fjords like Scandinavia. There's some places like that you think, these people eat seafood. There are places where people are surrounded by water, but they don't eat anything that comes from it. It's like water everywhere, but where's my fried calamari? And then there's other people who don't live near the water. They live inland, but they're eating a lot of river fish. That could be a whole other study on its own. Why does different cultures choose their diets in a way that doesn't seem to make evolutionary sense? But in any event, so those other isotopes, and I think a lot of that is a little more experimental, or just less used, but that can tell you more about a person's diet. Now, of course, there's the big three-letter word that everybody knows, DNA. DNA. That is extracted out of a bone that's in the ear. For some reason, it's dense with a lot of DNA material. I think it can be gotten in other places, but that's the place that they look for. Now, the technology around this is improving all the time. So more and more, they're beginning to recreate genomes from quite degraded material. They're getting better about that all the time. Now, there's two kinds of DNA analysis that's done having to do with archaeology. One is actually on modern populations. Now, when you look at the genomes of modern populations and get a sense of the different signatures, you can kind of link migrations and evolutions of people. So this is one of the primary ways that people started looking for example, where did the English come from? How much are they from the native Britons versus the people who came into the continent? There's the steppe cultures, which originated often near the Caucasus or near where Ukraine is or further east. They spread out, and people are using DNA to try to map where did they influence. And they often pair that with linguistics, Indo-European languages, and sort of trying to follow them. So you can look at modern DNA in populations. There are models that can get a sense of when there was an intrusion of DNA. So again, I'll just talk about what I know a little bit better. If you look at the British Isles, there was a native population who really weren't native because there were other people there before them, but that's a whole other thing. There was a native Celtic population. I put that in air quotes because Celtic is a very controversial term. Anyway, there was these native Britons. The Romans came in and left some imprint of DNA. The Anglo-Saxon Jutes came in, who left sort of a Germanic imprint. The Norman French came in and they left an imprint. And there are models. There's one called Globetrotter, for example, a tool that allows you to estimate when that intrusion occurred. So that's really cool. But that also has a very speculative element to it as well, because, for example, you have to make certain assumptions. So if you look at the British population, you can say, oh, all these German blood came in. That was after the British blood. So that was the Anglo-Saxons. But actually, if you've ever looked at a map, the south of England is not very far from Europe. So there were other people coming over too, Belgae, Frisian, and a lot of them have very similar DNA signatures. So these kind of modern population DNA studies can only take you so far. Now, the really cool one that we're beginning to see explode out onto the scene is the ancient DNA, or called aDNA. That is actually extracting DNA from 2, 3, 5, 8,000-year-old bodies you can find as an archaeologist. And they're getting better, as I mentioned, about extracting it even when it's degraded and being able to make, to tell stuff about the people. So of course, you can tell basic stuff like the sex, but you can see different markers in the DNA to sort of find out about their race or ethnicity, which obviously is very helpful for tracking human migration and population evolutions. And that's just, I can't think of all these long gone archaeologists who would have loved to have that tool. But even that we have to think about a little bit. It's not necessarily all it's cracked up to be. First of all, that can be really misused. Can we think of times in history where there were racial purity tests trying to judge people on whether or not they belonged somewhere based on their DNA? So DNA certainly means something, but does it define who you are? Does it define your identity? Does it define your ethnicity? Does it define your race? Those are all nebulous concepts. And they clearly, all of them have some relationship with DNA, but I don't know that that's actually really how we want to define groups of people by their DNA. Now, the other thing about DNA too is some of these markers they look for, again, in different populations, it's not actually that distinct. So there's an arc from, you can say, at least in the Iron Age and the Middle Ages, there was an arc from, let's say, the Netherlands, the northern Netherlands, all the way around northern Germany up to Scandinavia. A lot of that DNA matter and those signatures are very, very similar. So it doesn't necessarily allow you to make all the distinctions you think you can. But this is still relatively new, right? The human genome that was sequenced in my lifetime, I think like 1999 or 2000 or 2001, something like that. So this is sort of the gift that keeps giving, and they can do facial reconstructions based on it. They can tell the person's eye color. There was a big controversy a few years back where one of the oldest, maybe the oldest intact skeleton that's been found in Britain is Cheddar Man. I think he was called that because he was found near the village of Cheddar, like the cheese. And it was a big thing because they found out that he was actually dark-skinned, that his people at that time had not developed yet the gene to lighten the pigment in the skin that most people in the northern hemisphere have. And that created a huge, scandal, I guess, because people were saying, oh, they're trying to say that British people are black or they're African. And that actually shows you why this whole DNA question is kind of fraught. Because what actually defines a person's race? Is it their color? This dude they found had a direct descendant still living very close to where he died. That man was white as the driven snow. It just had to do with a skin pigmentation. So it gets you thinking, what does DNA really mean? What does race really mean? So it's more complicated than it seems. Now, there's soft tissue and hair, and as I mentioned, those are found in very, very specific contexts, usually either very dry, so going back to Egypt, you find those on human bodies because it's preserved in the dry, but it's also preserved in wet, waterlogged environments, and you wouldn't really think that. So in the northern hemisphere, that tends to be bogs, peat bogs, That's, you can find in Scandinavia, the British Isles, Ireland. And then also, more increasingly, we're seeing that in the US in tropical bogs like Florida and the Carolinas. They're finding very well preserved stuff. Now, I don't think there's ever been a bog body found in the Americas, but you find them in Europe. These perfectly, not perfectly, but you can really see these people. And a lot of it is quite gruesome because a long time ago, they ritualistically sacrificed people, and you can threw them in the swamp, and you can sort of see their facial expressions and very clearly how they died. I think that there was, in the Celtic times, there was a three sort of methods. Is Well, they used all of them at the same time: slit the throat, bash the head, and strangled. So yeah, you can see that in bioarchaeological remains. You can see even people's hairstyle. I mentioned Time Team. There was one episode of that where they found a very early medieval grave. I think it was in the Isle of Man, and they found the woman's hair braided. Really, really cool stuff. You could see what they looked like. Now, I know in modern bodies you can tell a lot from hair about diseases and health. I'm not sure if that's all preserved in ancient bodies, because most ancient hair, when it's found, does just kind of fall apart. But that's actually a good question to ask. Although perhaps that information is more easily gettable from bones and DNA, but food for thought. Now, let's not forget our animals, because animals are people too. And most people are like, well, why do you care about animals? What does that matter? Animals can tell you so much about people, because remember, we're archaeologists, we're studying the human past, not animals like as, biologists, right? We're not going to the Museum of Natural History, we're still in the Archaeological Museum. So, what can we learn about animals? We can learn about farming practices and the economy. We can learn about health, because it's not like all animals are pets or burdens of beasts. Some of them are parasites, like rats. You can learn a lot about rats, from rats rather, because rats like to collect things and then store it, and you can find out about that. But anyway, you can learn about what people ate. You can learn about their religious practices like sacrifices, or if they put, there's certain cultures like very famous site Çatalhöyük, where they put all of these cow skulls in very prominent places, so that the cow must have featured very importantly to them, also in Crete as well with the Minoans. You can learn about how people got around. You could learn about warfare, right? Warriors buried with their horse, and then of course all the horse fittings. So that meant a horse was a high status item that people fought with, or in a lot of history they didn't fight on horses, but they used them to get around quickly to battlefields. You can learn about their domestic life, because people kept pets very early on. You can even see that in ancient Egypt, thousands and thousands of years ago. You can find out about migration, because if people were herders, they brought their animals with them, and you can find out about how those animals evolved and figure out where the people came from as well. You can also do the isotope thing with animals, so you can find if the animals were brought from afar. Think about the different implications of that. If you find a burial ground and you find the animals and the people originated from different places, how did that happen? Maybe it meant there was some trade in cattle. That tells you then about the economy. So animals are a wealth of information about all aspects of human life. And then there's, of course, archaeobotany, because let's not forget about our plant friends. Now, archaeobotany can tell you, of course, a lot about people, what they ate, other uses they may have had for plants. Again, thinking of ancient Egypt, they found recipes for perfumes, and not a written recipe, although I think they have found that. They've been able to test residues and find out what was in the perfume. That was either in Egypt, it could have been in Greece also. They can find out about what grew in the area. And one of the really cool things is pollen analysis. So pollen analysis from the soil, that, I guess it's fossilized pollen, survives, and people can have a look at that and see what was growing around these people, because the soil that they're buried with. And there's been a lot of surprises about that. So, for example, again, I'll talk about England because that's what I know. there's this sort of belief. You watch Robin Hood and they're in Sherwood Forest, so right up through the Middle Ages the whole island was forested. That's actually not true. There were times over the deep history, prehistory, like Bronze Age, Iron Age, that there were fluctuations in forest amount of forest coverage based on how people grazed their animals, how they farmed. And there's been so many findings from this. They used to grow grapes in Scotland for the cultivation of wine, obviously showing that it was much warmer there then. They found, as I said, places that they thought were forested were actually cleared for crops. They found places that they thought this was a prosperous trading town. They actually found that it was probably overgrown and abandoned at that time because of what was growing around it. So archaeobotany can tell us a lot. Now, remember though, people often, when they say bioarchaeology, are not using this inclusive definition that I am. They often usually just mean people. The study of animals in archaeology is zooarchaeology, and the study of plants is archaeobotany. But you can include them all within bioarchaeology, so that's what I've done. B is for bioarchaeology. Hey, if you like what you heard, give me that thumbs up below, hit that bell to subscribe, or if you want to support more independent archaeology content, consider contributing to my Patreon, where you can enjoy some exclusive members-only benefits and other goodies. Until the next dig.